Hello everyone, and welcome to this session on course of occupational health. In this subtopic, we'll focus on introduction of occupational health, which focus the different forms of hazards that workers may encounter in the workplace. By the end of this topic, you'll know how to identify hazards, classify them, and understand the key legislation that governs workplace safety. Let's get started. In modern industry, health, safety, and the environment (HSE) are absolutely vital. While industries drive economic growth and prosperity, they also come with inherent risks, accidents, hazards, and pollution that can seriously affect workers' health, communities, and our environment. That's why it's important to strike a balance. Yes, productivity matters, but never at the expense of safety or sustainability. The guiding principle is simple: prevention is always better than cure. By taking proactive measures, industries can minimize accidents, reduce environmental harm, and create a safer, more responsible future for everyone. So as we move forward, keep this in mind: a truly successful industry is not just productive, it's also safe and sustainable. A simple but important question: what is a hazard? A hazard is any condition with the potential to cause harm or losses, not just to people, but also to machinery, equipment, property, and even the environment. Hazards come in many forms. They can be natural phenomena, like floods or earthquakes, or man-made occurrences, such as chemical spills, unsafe machines, or poor work practices. Accidents happen when hazards are not properly controlled. These accidents are unplanned and unintended events, but they can disrupt operations, cause injuries, and result in serious losses. That's why hazard identification and control are at the very heart of occupational health and safety. By recognizing hazards early, we can prevent accidents and create safer workplaces. Hazards take many forms: biological hazards from microorganisms, physical hazards such as noise and radiation, chemical hazards from toxic or flammable substances, and environmental hazards like pollution and land degradation. Each type requires a different strategy for prevention and control. Globally, governments are deeply concerned about HSE. For example, the Health and Safety at Work Act 1974 and related regulations require employers to protect both employees and the public. Specific laws, such as the COSHH Regulations 2002, ensure biological and chemical risks are properly assessed and controlled. In Malaysia context, the Occupational Safety and Health Amendment Act 2022 significantly expands the scope and strengthens the provisions of the original OSHA 1994. Key differences include a broader application to all workplaces, increased penalties for non-compliance, new duties for principals, and enhanced employee protections. The Amendment Act also integrates the Factories and Machinery Act 1967, FMA, into OSHA. These legal instruments form the backbone of occupational health, ensuring robust protection against workplace hazards. Biological hazards are often underestimated. They don't only occur in hospitals or laboratories, they can appear in many different industries, including construction, food handling, or even agriculture. The tricky part about biological agents is that, unlike chemicals, they can grow and multiply if conditions allow. So something that starts small can quickly become a big problem, leading to infections, allergies, or poisoning. This is why we must understand them well and act quickly before they spread. So where do biological hazards come from? In healthcare, workers and even visitors can be carriers of infectious agents. In biofacilities, waste and exhaust air can release microorganisms into the environment. Nature itself can also be a source. Microbes exist naturally in soil, water, and air, and can spread when environmental conditions change. Even the food and drinks we consume may contain latent microorganisms or toxins if not handled properly. In construction sites, for example, sources include contaminated water, dust in the air, soil exposure, and even animals. Knowing the sources is the first step in managing the risks. Now let's look at how microorganisms actually enter the body. They can get in through cuts or damaged skin, or through needle-stick injuries and bites. They can also be inhaled into the lungs or swallowed, leading to respiratory or digestive infections. Some diseases are spread through blood or body fluids, while others use vectors like mosquitoes. So the big message here is, once we understand the entry routes, we can put in place specific protective measures to block them. Here are a few real-world examples. Waterborne infections like cholera, typhoid, or Legionella come from contaminated water supplies or plumbing systems. Aerosol-borne infections can spread in wastewater treatment plants. Fungal hazards, such as Cryptococcus from dried bird droppings, can cause pneumonia-like symptoms. And even something as common as wood dust can become dangerous when contaminated with fungi, leading to nasal cancer or occupational asthma. These examples remind us that hazards aren't always obvious, they can be hidden in everyday environments. Let's talk about the hazards we can't always see, but that are just as serious as anything else out there. I'm talking about physical and environmental hazards. Think about it, the very air we breathe can be a major source of danger. We're all familiar with air pollution, right? That stuff that comes from burning fossil fuels, mining operations, or even the exhaust from cars and trucks. It doesn't just contribute to smog and greenhouse gases, it can have a direct, dangerous impact on people's health in the workplace. And what about a place like an underground tunnel or a mine? You might think the biggest risk is a cave-in, but what about the invisible dangers? Foul gases like carbon monoxide and carbon dioxide can get trapped, creating a deadly, odorless environment. These are silent killers. And then there's the unpredictability of nature itself. A sudden flood, or a water influx, in an underground site can be catastrophic. It can destabilize the entire rock structure, leading to a collapse and putting everyone's lives at risk. The key takeaway here is that not all hazards are visible or tangible. The working environment itself can be a source of grave danger. These unseen factors can drastically change a safe workplace into a life-threatening one in a matter of seconds. It's why we always have to be aware of the environment around us and the potential for things we can't see to cause harm. Another hazard are ground condition hazards. When we think about tunneling or excavation, our minds usually go to the massive machines or the sheer scale of the project. But the real, serious risk often lies right under our feet or, more accurately, under the ground we're working on. The ground isn't always stable. It can collapse, deform, swell, or even be affected by seismic activity. This isn't just a minor inconvenience, it's a huge deal. In fact, studies have shown that more than 95% of all tunneling incidents are directly linked to ground failures. That's a massive number, and it tells us something critical. You see, you can't just start digging. Before a single shovel hits the dirt, we need to have a deep understanding of what's going on underground. We do this through detailed geological surveys and by setting up monitoring systems. Skipping this step is like trying to build a house on quicksand. You might get the foundation in, but it's only a matter of time before problems start popping up. So, the lesson here is this: in tunneling and excavation, the ground isn't just where we work, it's a potential hazard we have to respect, understand, and plan for. As we bring in more machines and automation, we're seeing some new kinds of risks popping up. First off, let's talk about electrical hazards. With all this high-powered equipment, the danger of electrocution, burns, or even fires becomes a much bigger deal. We have to be on top of our game with electrical safety standards, making sure everything is regularly inspected and well maintained. Then there are the dangers of moving machinery. Think about the risk of getting hit by a moving part or, even worse, getting trapped in a machine. This is where proper guarding systems are non-negotiable. We need physical barriers and automatic safety sensors to keep human operators out of harm's way. The big picture here is this: mechanization and automation are awesome for making work faster and more efficient. But we can't just set it and forget it. We have to be proactive and make sure that as we protect the process, we're also protecting the people. Technology only works safely when the humans using it are completely protected. We already learn what is hazard. Now, it's you to control it. As safety officer or safety coordinator, this process are very important. So, what's our main tool to manage hazards? Risk assessment. This isn't just paperwork, it's a legal requirement for employers. The purpose is simple: to create a working environment that minimizes injuries and illnesses. When done properly, risk assessments reduce the frequency and impact of incidents. Think of it as shining a spotlight on potential dangers so we can address them before they become accidents. Risk assessment follows a clear, step-by-step process. This thorough risk assessment isn't just a checklist, it's a proactive, 6-step framework designed to identify and manage hazards effectively. Step 1: Hazard Identification. First, we must meticulously identify all hazards present in a specific work task or environment. A hazard is anything with the potential to cause harm. This includes obvious dangers, like exposed wires, and less obvious ones, such as a repetitive motion that could lead to a musculoskeletal disorder. Step 2: Who is at risk? Next, we determine who could be affected by these hazards. This analysis must go beyond just the employees on the job. Consider visitors, contractors, maintenance staff, or even the public, as their proximity or interaction with the work area can expose them to risk. Step 3: Analyze and evaluate the risk. Now, we analyze the risk. This involves a two-part evaluation. Consequence: what is the potential severity of the harm? Is it a minor cut, a severe injury, or a fatality? Likelihood: how probable is it that the harm will occur? Is the risk a frequent occurrence or a rare event? This step allows us to quantify the risk and move on to prioritization. Step 4: Risk Ranking and Prioritization. Using the analysis from Step 3, we rank the risks. A common tool for this is a risk matrix, which plots likelihood against severity to give us a clear visual of which risks are the most critical. This prioritization ensures we focus our resources on the most significant threats first. Step 5: Decide on control measures. With our priorities set, we decide on control measures. The ultimate goal is to eliminate the risk entirely, but when that's not possible, we look at a hierarchy of controls. We ask, can we avoid the risk, transfer it, for example, by outsourcing a hazardous task, or reduce it through effective controls? Step 6: Implement and monitor. The final, crucial step is to implement the treatments. This could involve a range of actions, from engineering controls like installing better ventilation, to administrative controls such as creating new safety procedures, and finally, to providing the appropriate personal protective equipment, PPE. However, the process doesn't end here. We must continuously monitor the effectiveness of these controls to ensure they remain adequate and that the workplace remains safe. By following these 6 steps, we build a foundation for a proactive safety culture where we don't just react to incidents, but actively prevent them. Tools. For example, in the realm and handle of biological hazards, we don't treat all agents equally. For safety and risk management, biological agents are categorized into 4 distinct groups, known as hazard groups or biosafety levels. This classification system is crucial because it dictates the level of containment and precaution required when working with these materials. Hazard Group 1, the baseline. Hazard Group 1 contains organisms that are unlikely to cause human disease. Think of common, non-pathogenic bacteria found in research or educational settings. These agents pose a minimal threat to laboratory workers and the community, and standard microbiological practices are generally sufficient for safe handling. Hazard Group 2, the controlled threat. Next, we have Hazard Group 2. These agents can cause human disease, but they are considered unlikely to spread to the community. Moreover, effective prophylaxis or treatment is typically available. Examples include agents that cause illnesses like influenza or salmonella. While they require careful handling, the risk of a widespread outbreak is low. Hazard Group 3, the serious risk. Hazard Group 3 agents pose a serious hazard because they can cause severe human disease and present a risk of spreading to the community. While effective treatments may exist, the potential for a serious public health impact is significant. A well-known example is the bacterium that causes tuberculosis. Work with these agents demands specialized facilities and strict control measures to prevent accidental release. Hazard Group 4, the highest level of danger. Finally, we have Hazard Group 4, which represents the most dangerous biological agents. These are agents that cause severe human disease, are likely to spread easily through the community, and for which no effective prophylaxis or treatment is available. The Ebola virus is a classic example. Handling these agents requires maximum containment facilities, often referred to as Biosafety Level 4 labs, which are designed with extreme measures to protect both workers and the public. By understanding these classifications, we can implement the correct level of safety protocols, from basic lab hygiene to highly specialized containment, ensuring the protection of individuals and the broader community. Now, if you're like most people, when you hear workplace safety, you probably think of things like hard hats or safety goggles, right? But that's actually the very last line of defense. The true pros in occupational safety and health, like us, think about it in a much smarter, more strategic way. Imagine this as a pyramid, or maybe even a ladder. We always want to start at the top, which is the most effective and reliable way to control a hazard. At the very top, our first and best option is elimination and substitution. This is where we completely get rid of the hazard. Can we just remove that dangerous chemical from the process? Or if not, can we substitute it for something much safer? Think of it this way: if you don't have the hazard there in the first place, you don't have to worry about it. It's the ultimate solution. If we can't eliminate it, we move down one step to engineering controls. This is where we use our skills to physically change the workplace to protect people. We're building safety right into the system. This could be something like a state-of-the-art ventilation system that sucks up harmful dust, or installing a guard on a machine so a worker can't accidentally put their hand in the wrong place. These are great because they work automatically, without relying on a worker remembering to do something. Next, we have administrative controls. This is about changing how people work. Think of this as the rules and procedures we put in place. This could be a new training program on how to safely handle a tool, rotating shifts so no one is exposed to a hazardous task for too long, or even just putting up clear warning signs. These are useful, but remember, they depend on people following the rules, so they're not as reliable as our engineering controls. Finally, at the very bottom, is personal protective equipment, or PPE. This is our last resort. We're talking about things like gloves, goggles, and respirators. Now, don't get me wrong, PPE is crucial. But it only protects the individual person wearing it, and it doesn't solve the core problem. It's the final barrier. So we should only use it when we can't do anything else, or to add an extra layer of protection on top of our other controls. So, when you're out there assessing a workplace, always start at the top of the pyramid. Try to eliminate the hazard first. Then, if you can't, engineer a solution. Use administrative controls to back that up, and only then, rely on PPE. This systematic approach is what truly makes a workplace safe. The hierarchy of controls gives us a clear strategy. At the top is elimination, which is the most effective: remove the hazard completely. If that's not possible, try substitution, replacing it with something safer. Then come engineering controls like barriers, ventilation systems, or machine guards that separate people from the hazard. Next are administrative controls like rules, training, or job rotation. At the very bottom is PPE. Why at the bottom? Because PPE only protects the individual, and it can fail if not used properly. The idea is to always start at the top and work your way down. Let's zoom in on engineering controls. Take mines and tunnels, for example. Mechanical ventilation is essential to control air quality, temperature, and humidity. Without it, workers could be exposed to toxic gases or heat stress. In situations with emerging biohazards, we may need advanced systems like high-efficiency particle filtration or UV germicidal irradiation. These systems may be costly, but they provide a strong barrier between hazards and workers, which makes them highly effective. Engineering controls are great, but they don't work alone. That's where administrative controls come in. This includes ongoing training, refresher courses, safety drills, and even things like posters and safety campaigns that keep awareness high. Incentives like rewarding safe workers also help encourage good practices. And let's not forget safety audits, which ensure that procedures aren't just written down but actually followed in daily work. Together, these steps build a strong safety culture. Proper management of biowaste is critical. Waste should always be contained in biohazard bags or boxes that are color-coded for clarity. These containers must be autoclavable to allow sterilization. For liquid wastes, chemical inactivation or autoclaving is necessary. Solid wastes must also be sterilized before disposal. After deactivation, waste should be transferred to a different bag color to signal they are safe. It might sound like a lot of steps, but these practices prevent accidental spread of dangerous biological agents. Another powerful concept in safety, the life cycle approach. Think about it this way: a lot of people think about safety only when a project is running, like when a tunnel is being dug or a factory is in full swing. But the truth is, some of the most critical safety decisions are made way earlier, before a single shovel hits the ground. The pre-construction stage is actually the riskiest because that's when we're making big-picture decisions about design and planning. If we have poor planning or design flaws at this point, they can come back to haunt us later as accidents, costly delays, or even structural failures. It's like designing a car with faulty brakes. The problem isn't going to show up until you're already on the road. By adopting a life cycle approach, we integrate safety into every single stage of a project, from the initial planning and design, through construction, during its entire operational life, and even to its eventual closure. By doing this, we're not just reacting to problems, we're actively preventing them. And that not only saves lives but also reduces long-term risks and costs. It's a win-win for everyone involved. You see, emergencies can strike at any time, and when they do, a quick, confident, and coordinated response is the difference between a minor incident and a tragedy. That's why having a solid emergency management system isn't just a good idea, it's essential. So, what does that involve? It's all about being ready before disaster hits. First, you need a clear plan. This isn't something you just jot down on a napkin. It needs to be a detailed roadmap that outlines what actions to take, where the evacuation routes are, and who to contact. Next, you need to assign responsibilities. Everyone on the team should know exactly what their role is during an emergency. Who's in charge of a headcount? Who's responsible for shutting down a specific machine? When everyone knows their job, there's no confusion. And finally, you need training. A plan is useless if no one knows how to follow it. We need to practice our responses and make sure every worker is trained to act effectively. The main idea here is to eliminate hesitation. When an emergency happens, every second counts. By having a clear plan and the training to execute it, we can act quickly and confidently, which can literally save lives. Let's talk about the critical time right after an accident happens, the moment before professional help arrives. This is where first aid comes in, and it's a game changer. Adhesive bandage. Think of first aid as the immediate bridge between an accident and professional medical care. It's about having trained people on hand to quickly treat injuries. This is especially important when we're dealing with biological hazards, because a quick response can prevent a minor issue from becoming a serious infection. But first aid is only part of the puzzle. Just as important is incident reporting. When something goes wrong, workers have to report it immediately. Why? Because this allows us to activate our emergency plans. It's like a domino effect. One small report can trigger a whole system designed to keep everyone safe. This is super critical when there's a risk of infection spreading, not just in the workplace, but to the wider community. We need to be able to respond rapidly and contain the problem. So remember, quick treatment and immediate reporting go hand in hand to prevent a bad situation from getting worse. I want to leave you with one of the most important takeaways from this course. Safety isn't a one-person job, it's a shared responsibility. Handshake. You see, a lot of people think safety is just for the safety officer or the manager. But that's a dangerous way of thinking. For a workplace to be truly safe, everyone has a part to play. Management's role is to lead by example. They have to provide the right resources, like proper training and the best equipment. They're also responsible for making sure the working conditions themselves are safe. Employees have a huge part to play, too. It's their responsibility to follow the safety procedures they've been taught and, most importantly, to report any unsafe situations they see. If you see something, say something. And let's not forget about our partners, the contractors, consultants, and safety experts who work with us. They're all part of the team, and their coordination and expertise are absolutely vital. When everyone works together and takes their responsibilities seriously, we build a strong, resilient safety system. But when even one person ignores their role, the entire system can break down. Collaboration truly is the key to a safe and healthy workplace. Tools. As a conclusion, the final goal of occupational health is simple, that is to create a safe and healthy environment for both workers and the community around them. But how do we get there? It's not magic, it's a systematic process. First, we have to understand the hazards we face. Then, we need to assess the risks they pose. And finally, we apply the most effective controls to manage them. Here's the key takeaway I want you to remember: investing in safety early on always pays off later. When you prioritize safety during the planning phase of a project, you save lives, prevent accidents, and avoid massive costs down the line. Beyond that, it builds a foundation of trust. A safe workplace isn't just a good ethical choice, it's also just plain good business. It shows that a company values its people, and that's something that benefits everyone. Thanks for your attention, and let's go out there and build safer workplaces. Tools.